Hello guys, welcome back to the session. Today we will learn what are regular expressions and how to build them. So let's get started by understanding some of the facts of regular expression. So regular expression is a sequence of characters which define a search pattern used to match character combinations in a text. Now this regular expression is very powerful as it is supported in all scripting languages such as Perl, Python, PHP, JavaScript, and also in programming language such as Java, and it is also supported in word processors such as Word. Now these regular expressions are used in search engines, search and replace dialogues of word processors and text editors and etc. So let's get started to learn how to build our own regular expressions. Now to create and build regular expressions, I will use this online tool. I'll share this link in the description. Now in this tool, here we write the regular expression and here we write the text where we want to search for patterns. So as of now, I have provided this text, first demo and second demo, and here we will write the expression. Now the regular expression we write in between two forward slashes. Let's say that if I write here demo, so this demo I have provided in between two forward slashes, and here you see these has been matched. The demo text has been matched. Now after this forward slash there is a character called G. So what is this G? This G is for a flag called global. So if you click on the drop down of this flag, here we have multiple of flags present. First one is global. Now as this flag is set, it is matching all the occurrences of demo in our text. But if we reset this flag, if we reset this global flag, here you see only the first occurrence of demo is getting matched. The second occurrence of demo is ignored. So let's go with this global flag. We'll set this global flag. Now next flag with us is case insensitive. Now let's say that if I provide here demo in D small, so here you see this demo is not getting matched since we have differences in cases. This has the uppercase and this one is the lowercase. So if I set this character insensitive flag, so here you see now both the demos are getting highlighted. Both the demos are getting matched now. So we'll go with these both of these flags as set, that is global and case insensitive. Now let's look into some other ways of writing the regular expressions. So now let's learn about character classes. Character classes matches a character from a specific set. So let's look into these examples. Now here in the expression, if I provide a forward slash and W, this expression matches any word character, and word characters are alphanumeric and underscore. Now here if I put 1, 2, 3, it is matching the numbers 1, 2, 3. If I provide here underscore, it is matching that also. But if I write here underscore, hash, dollar symbol, these are not getting matched since these are not word characters. Now what if I want to match these characters instead of all these alphanumeric and underscore values? So for that what we will write? We will write forward slash and W in caps on. So here you see all these characters which are not word characters are getting highlighted. So this space is also not a word character, that's why it is also getting highlighted. Now what if I want to match only these three numbers? So to match the numbers, what expression we will write? We will write a forward slash and D in small. So by this expression, you see all the numbers are getting highlighted. All the digit characters are getting highlighted. If I write here the expression as forward slash and D in caps, this is the reverse of the previous one. Any character which is not a digit character are getting matched. Now let's say that from this text you want to match all the vowels present in this text. So how to do that? So for that I'm going to put the square brackets, and in the brackets I'm going to write A, E, I, O, U. So whatever characters you provide inside the square brackets, every character provided here will be matched inside the text. So you see here all the characters present inside this square brackets, which is basically the vowels, are getting matched in this text. Next, if you provide a caret symbol in this regular expression, this expression will do the reverse. That means it will match any character that is not present inside the set. So this caret symbol will perform the reverse of the expression without the caret symbol. Next, let me tell you about the capture groups. So let's say I have written here first demo and then I write here first demo, where this is in caps on, this F is in caps on, and this F is in caps off. Now if I provide here first, and if I reset this case insensitive, so here you see only this first gets matched, since the F is in lowercase here and the F is in lowercase here, but this is not matched since the F is in uppercase. Now to select both these first, in spite of flag reset or not, what we will do, we'll use capture grouping. So to work on capture grouping, what we do, we use moon brackets. So open the moon bracket, provide F in uppercase, put the pipe symbol, and this is our lowercase f present, and close the moon brackets. So here you see both the first got matched. So this in the brackets, this is called the capture grouping, and this pipe symbol, this symbol acts like a boolean, or it matches the expression before or after this pipe symbol. So hence both these first gets matched. Now let's learn about quantifiers. So the quantifiers indicate that the preceding token must be matched a certain number of times. Let's look into some of the examples. Let's remove this expression, and if I provide here demo, demo and dem. Now here if I write MO, so all the MOs are getting matched. Now what if I put a plus symbol here? So this plus symbol matches one or more of the preceding token, and in our case the preceding token is O. So this plus symbol will match one or more of the preceding tokens. So here we have one O, that's why this MO is matched. Here we have multiple O's, that's why this is matched. Here we have two O's, so this also satisfies the criteria. This is also matched. But here you see there is no O present. That's why this is not matched and all these O's are matched. Now if I provide here question mark, so what happens here? This expression matches between 0 and 1 of the preceding token, that is O. So accordingly here we have the match M and 1O. Then again here M and 1O, similar here. But here you see even though O is not present, M gets matched, since this question mark makes O as optional. This question mark says the text can have 0 or 1O. Now since the O is not present here, even though the O is not present here, this gets matched, and accordingly this MO and this MO also gets matched. Now if I look into some other quantifier, say star, so this star quantifier matches 0 or more of the preceding token, and the preceding token is O here. So here this one O gets matched along with M. Here multiple O's gets matched. Here two O's gets matched, and here even though O is not present, but since it matches 0 O's also along with M, that's why this gets matched, and accordingly for this one also. But what if you want to find the exact number of O's? Let's say that you want to find O which are 5 in count. So how to do that? So for that what you will write here O, and in the curly braces you will provide here 5. So here you see the 5 O's gets matched as we provided 5 in the brackets. Now if you want to match O's in the text of count 2, 3, 4 and 5, so what you will write? 2, comma 5. So all the O's in the text will be matched for 2, 3, 4 and 5 count. So here we had 5 O's, it gets matched, 2 O's gets matched. If I write here demo, it also get matched, 4 O's also gets matched, 5 also get matched. But if I provide here 6 O's, the last O didn't match since we have provided here higher boundary as 5. But what if I remove this 5? So all the O's will get matched here in the text starting from count 2. So this 2 O's get matched, 6 O's, and whatever number of O's we provide here starting from count 2, every O will get matched. So that was about the quantifiers. Now let's learn about the anchors. Anchors match a position within the string. They don't match the characters. These are only specific to match the positions within the string. So let's look into these examples. So this is our new text, invoice number generated for Jan month, invoice number generated for Feb month, delay in invoice generation for month March. Now from this text, let's say that I want to match the invoice which is present at the beginning of each line. Now if I simply write invoice here, so here you see the invoice which is present in the middle of the line is also matched, which is not our requirement. Now to match our requirement, to match the invoices present at the beginning of each line, what I will write, I will put a caret symbol at the starting of the regular expression. Now this invoice is not matched, that is fine, but this invoice should match, which is not getting matched now. So what is happening? This caret symbol is matching the beginning of the string, which is invoice, but it is not matching the beginning of each line. Now to match the invoice at the beginning of each line, we will enable a flag say multi-line. So here you see, as soon as we enable this multi-line flag, the invoices gets matched at the beginning of each line. In a similar way, if you want to match this month here, so if I simply write month, so our requirement is to match these 2 months, but this month is also getting matched, which is present at the middle of the line. But we want to match the month present at the end of the line. So what we will do, we will simply put a dollar symbol here, and here you see our requirement satisfies. So this was about the anchors, caret and dollar symbol. Let's learn something else now. Look around lets you match a group before, that is look behind, or after, that is look ahead, your main pattern without including it in the result. So let's look into these examples. So let's see how we can search for these invoice numbers using the positive look behind. So for that I will write the expression. So first of all I will write a capture group, and inside this capture group I will write question mark less than equal to. This less than is for look behind and equal to is for positive. So overall this is the expression for positive look behind. So here I want to search for the invoice numbers. So I will write this number and space which comes behind the invoice number, or we can say which comes before the invoice number which we wish to search. So here I will write number and space. Now after this capture group, if I put a plus here, so here you see first character of invoice number is getting matched. Now if I write more dots, all the characters are getting matched. So this dot matches any character except the line breaks. So this is the use of dot. Now instead of writing this dot 6 times, we can also write a single dot, and the quantifier inside the curly braces I will write 6. This is the quantifier we just learned few minutes back. So writing this expression, you see we match the invoice numbers using the positive look behind. Now one more expression we can write here is, instead of this dot we can also write a forward slash and W, which we learned just few minutes back. This forward slash with W matches a word character which is alphanumeric and underscore. So I will write forward slash W and the quantifier 6. So this is the total expression by which the invoice numbers gets matched. So this is the complete expression of positive look behind by which the invoice numbers get matched. Now if you want to use the negative look behind, what you will do, instead of this equal to, you will provide an exclamation mark which stands for negative look behind. So negative look behind specifies a group that cannot match before the main expression, and hence this is the result. So now we will learn positive look ahead, and using the positive look ahead we will fetch the Jan and Feb month. So let's see how we can do that. So first let's write the expression of positive look ahead. So for that, again inside the capture group I will provide question mark equal to. This is the expression of positive look ahead. Now here I want to search for Jan and Feb, ahead of which or after which the text is space and month. So I will provide this text inside the capture group, and before this capture group I will write slash W, and the quantifier I will use inside the curly brace as 3. So here you see this Jan and month gets matched, and we also see here this for is also getting matched, and this also comes inside the pattern, but we do not want this to be matched. So what we will do here, as we just learnt about the anchors, I will use this dollar symbol here which denotes the end of the line, as we already learned few minutes back. So now you see our requirement gets satisfied, only the Jan and Feb months are getting matched, this for is not getting matched. Now one more thing to notice both for look behind and look ahead is that the text which we provide inside the capture group is not matched inside the text. This is the feature of look behind and look ahead. So this is how you can work on the look behind and look ahead inside the regular expression. So as of now we have learnt most of the features of regular expression. Let's practice regular expression now by creating a one for the phone numbers. So I have some sample phone numbers with me. Let me provide it here. And here you see we have different samples of phone number. First two are simple 10-digit phone numbers. Then we have phone number with a plus symbol and 91 as country code. Then we have a space, dash and space in between the code and the 10-digit phone number. So let's build a regular expression which is going to match all of these phone numbers. So first of all, I will write the regular expression starting from 10-digit phone numbers. Here you see the phone numbers could start with 6, 7, 8, 5 or 9. So for the first digit of the phone number, I'm going to provide inside the character set as 5, 6, 7, 8, 9. So it will match any character inside this character set. And then I will provide the quantifier as 1 since this is only for the first digit of the phone number. Then the remaining 9 digits could be any digit from 0 to 9. 0 to 9. So I have provided it in the character set. And the quantifier I will provide as 9. So now here you see the first two phone numbers get matched properly. Let's look how we can match these phone numbers. So here we have a plus symbol, and this plus symbol is optional. Some phone numbers have plus symbol, some phone numbers do not have. So what I will do for the plus symbol, I will write this as forward slash and plus since this is a escape character. And since this is optional, I will provide a question mark which we learned few minutes back. Then this 91 is also optional. Few phone numbers have 91, few phone numbers do not have. So inside this capture group, I will write 91 and here I will provide question mark. Now here you see this third phone number is also getting matched properly. Now let's see how we can match these phone numbers which has space, dash and space in between. So these are also optional, so I will provide a space, then question mark since this space is optional, then a dash, and since this dash is also optional, so I will provide dash and a question mark, and similarly again space and question mark. So here you see all these phone numbers gets matched. So in this way we write the expression, regular expression to match all these phone numbers. So in this way you can build your own regular expressions according to your requirement. Once the basics are clear, regular expressions are very helpful and easy to be worked on. And that's all for this session guys. I hope you enjoyed this video, and if you did, give it a like and share with your friends. Hit the bell button to get the updates on the latest videos. And if you have not yet subscribed to our channel, please subscribe to our channel as well, and I'll see you soon in the next one. Bye bye.